All right, today we're going to be looking at how to solve logarithmic equations. So this is chapter 7, topic 5. This would be equations where you're solving for the variable and they have a log in them. The idea here to solve these is to simply switch the form, switch it into exponential form, and then solve the exponential. Okay, so number 1, we have log base 3 of x is equal to 4. And if we switch this into exponential form, so 3x4, then we get 3 to the 4th is equal to x. 3 to the 4th is 81, so 81 is equal to x. So that's our solution, 81. Number 2, log base 36 of x equals 3 over 2. We want to solve this equation for the variable x. So we will switch it into exponential form. So 36x, 3 over 2. So we have 36 to the 3/2 power equals x. Okay, so now we just got to figure out how to evaluate 36 to the 3/2 power. So remember, 36, the denominator of 2 means we're taking a square root of 36. And then the exponent of 3 means we're raising it to the 3rd power afterwards. So the denominator of 2 means a square root of 36, and the exponent of 3 means we're raising it to the 3rd power. You can do these in either order, but I'm going to take the square root first and then raise it to the 3rd power. So that would be 6. Square root of 36 is 6. And 6 to the 3rd power is 216. So our solution here is 216. Number 3, x plus 2 equals log base 5 of 125. Now, if you want, you can write the log on the left side if it's easier to look at. Log base 5 of 125 equals x plus 2. Either way, that would be up to you. Okay, so I'm going to write here 5, 125, x plus 2. Okay, so I get 5 to the x plus 2 power equals 125. And I need to solve this exponential. Okay, so I need to express 125 as a base of 5. 5 to the x plus 2 equals 5 to the 3rd power. Now that the bases are the same, I can set the exponents equal to each other. X plus 2 equals 3. Subtract 2, and x is equal to 1. So 1 is the solution to my equation that I started with. All right, log base 2 of 3x minus 1 equals 3. All right, so 2, 3x minus 1 equals 3. So we have 2 to the 3rd power equals 3x minus 1. And 2 to the 3rd power is just 8. So 8 equals 3x minus 1. And this equation we can just solve. We'll add 1. Gives us 9 is equal to 3x. And we'll divide by 3. So we got x is equal to 3. So our solution is 3. Number 5, we have log base 2 of x squared minus 4 equals log base 2 of 3x. Okay, now when we got something like this, we got log base 2 of this and log base 2 of this, then those two things must be equal to each other. Okay, so we just, sorry, where was I? Okay, as I was saying, because the, whoops, because the bases are the same, these are both log base 2, then what's inside the logarithm must be equal as well. So x squared minus 4 and 3x must be equal. So we say x squared minus 4 equals 3x. And then we solve this. So we move the 3x over here. So we got x squared minus 3x minus 4 equals 0. And this is a quadratic, so we need to solve it like we would a quadratic, okay? So we're looking for numbers that multiply to negative 4 and add to negative 3. And that would be negative 4 and 1. Negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. So this is x minus 4, x plus 1. So our solutions would be 4 and negative 1. Now, one of these is not going to work, okay, because this only has one solution. So let's try these solutions and see which one is going to work. Okay, so log base 2 of 4 squared minus 4. So log base of 2 of 12 is equal to log base 2 of 3 times 4. So I'm plugging in 4 right now. So 3 times 4 is 12. So this is fine, okay? Log base 2 of 12, log base 2 of 12, that's fine. But if we see what happens when we try to do negative 1, okay, so I plug in log base 2, negative 1. So negative 1 squared is 1, minus 4 is negative 3, equals log base 2 of negative 3. Now, this is a problem because you can't take a log of a negative number. All right, there's no such thing as taking a log, because what are you going to raise this to get negative 3? What power are you going to raise it to? Okay, so negative 1 is not a solution here. The only one that works is 4. Okay, negative 1 doesn't work, so we can't use it. So the solution here is 4. All right, number 6, log base 9 of x squared minus 4x equals log base 9 of 3x minus 10. Okay, so just like from before, the bases are the same. It's a log base 9, log base 9. So we can just set the what we're taking a log of equal to each other, the x squared minus 4 equal to the 3x minus 10. Now, we can see this has an x squared, so it's going to be a quadratic. So to solve it, we need to set it equal to 0. So we got x squared minus 7x equals negative 10. And then we have to add 10. And we end up with x squared minus 7x plus 10 equals 0. And now we can solve this quadratic. So we're looking for numbers that multiply to 10 and add to negative 7. So that's negative 5 times negative 2, negative 5 plus negative 2. Okay, so this factors into x minus 5 and x minus 2. So our possible solutions are 5 and negative 2. Now one of these isn't going to work because one of them is going to give us a negative when we plug it in. Okay, and it's the negative 2. Okay, if we plug in negative 2 into 5 squared minus, yeah, if we plug the negative 2 into this, 3x minus 10, we would get negative 16. If we plug it in over here, we get 4 plus 8, 4 plus 8, which is 12. So these don't even end up being equal to each other anyways, but one of them is negative. So the negative 2 is not going to work. Only the 5 is going to work here. Because if we plug in 5, we get 25 minus 20, which is 5, and 15 minus 10, which is 5 as well. So 5, this is the only one that works. Okay, if you plug in negative 2, not only does it give you a negative, these two don't even end up being equal to each other. Well, yeah, they do. They have to. Negative? Oh, that's why. Sorry, that solution is positive 2. I was like, why is it not equal to each other when I plug it in? But it will be if I use 2. But the problem still shows up when I plug 2 in, okay? Because if I plug it in to either of these, they both are negative, okay? So 2 does not work. Sorry, I used negative 2. It should have been 2. 2 does not work because when you plug it in, you get negatives, and you can't take a log of a negative. So 5 is the one that works. All right, here's the homework for this lesson.